Introduction to Quantum Computing. Hello and welcome to this 5-minute introduction to quantum computing. Quantum computing is a fascinating field that combines the principles of quantum mechanics and computer science to perform computation. It has the potential to solve problems that classical computers can't and has applications in a range of fields from cryptography to simulation, optimization and machine learning. Classical computing versus quantum computing. To understand quantum computing, it's important to first understand classical computing. In classical computing, computers store information in bits, which are binary units that can only have a value of either 0 or 1. However, in quantum computing, we use quantum bits or qubits, which can exist in multiple states simultaneously. This is known as superposition. Superposition and entanglement. Superposition is a key aspect of quantum computing and allows quantum computers to perform certain computations much faster than classical computers. Another quantum mechanical property called entanglement can be used to perform operations on all qubits at once, further increasing their computational power. Quantum algorithms. Quantum algorithms have been developed to take advantage of these properties, solving problems such as factoring large numbers and searching large databases much faster than classical algorithms. One famous example is Shor's algorithm, which can factor large numbers into primes in a fraction of the time it would take a classical computer. Building quantum computers. However, building and using quantum computers is challenging due to the delicate nature of qubits and the need for precise control and low temperatures. Despite these challenges, the field of quantum computing is rapidly advancing and companies such as Google, IBM, and Microsoft are investing in its development. Applications of quantum computing. Quantum computing has the potential to revolutionize the field of computing and has applications in a range of fields. For example, in cryptography, quantum computers can break current encryption methods, but they can also be used to create new and secure encryption methods. In simulation, quantum computers can simulate quantum systems with much greater accuracy than classical computers. Future of quantum computing. The future of quantum computing is exciting and holds great potential for solving some of the world's biggest problems. Despite the challenges, researchers and companies are working hard to build practical and useful quantum computers that can be used to tackle real-world problems. Conclusion. In conclusion, quantum computing is a fascinating field that combines the principles of quantum mechanics and computer science to perform computation. It has the potential to solve problems that classical computers can't and has applications in a range of fields. The field is rapidly advancing and holds great potential for the future. Thank you for joining me for this 10-minute introduction to quantum computing. I hope you have a better understanding of what quantum computing is and its potential. If you're interested in learning more, I encourage you to explore the field further. Until next time, goodbye.